Hey everybody, welcome to day number 2, April 6th through 8th. Um, so on the e-learning page for the 6th through 8th, make sure, again, you watch the update, all right? That just gives a quick recap of day 1, as well as some introduction or some information, just some expectations for day 2 and also day 3. I'm not going to have an update for day 3 itself, so the update here will be for day 2 and 3. So for today, we are going to focus on, as the update said, on titrations, chemical titrations. So on Haiku, make sure that you open up the document labeled or titled Titrations Introduction Notes and Classwork, or notes/classwork. Looks like this. Again, for all videos, just pause them if you need to. All right, no big deal. Email me if you have questions, as always. So this will be due today, or I guess by the end of Wednesday. I hope you get it done by the end of this class period, I guess. Again, these are required, so make sure that you turn these in, okay? So titrations, I love titrations. Okay, they are my favorite part of chemistry. It's basically a big mishmash, big mashup of a bunch of different concepts in chemistry. And I wish that again we were in class to do the actual experiments. We do a ton, or we have done a ton of titration experiments. So for this document, it just kind of goes through the basics of a titration. It's kind of like a mystery, kind of like a game. The whole purpose is to determine the molarity of a solution. This is done by knowing or using a solution, a different solution with a known molarity or a known concentration. So I relate it also to algebra with two variables or two unknowns and one equation. The way that you solve for the two unknowns is you need another equation. And so titrations, you have an unknown molarity and a known molarity, and you have to use those in tandem with each other. They're in tandem to figure out the unknown molarity. And the balanced equation is the missing piece for a lot of titrations. And we'll get to that eventually. Again, for titrations, we're doing them for 2 days. All right. So the second day, in other words, day number 3 total, so day 3 of e-learning will be more complicated titrations. So titrations, as I explained in the update, they involve the use of a burette. I don't have a burette, so any video I post of me doing any kind of titration involves pipettes, not burettes. Check out the video right here, so you can stop this and check this video out on the basics of using a burette. They show you how to, the video shows you how to clean it, shows you how to measure in a burette, shows you just how to use it for the most part. And then you can read through here about the importance of titrations in the science world. This is a big one here. Presence of a virus in a sample. There you go. So in this document, we're going through a hypothetical titration just to learn the basics. Okay. So normally in class, we would do like a sample lab titration to learn how to use it, but we're going to have to do that online here. So let's say in general that a bottle of NaOH is mislabeled, the label is gone, and we don't know what the molarity is. It could be 0.01, could be 10 molar. Again, big difference between those two. So this is one use of a titration, is to figure out a molarity of this random base in a chemical storage closet. Okay. So in order to do this, we need to know something about what we are titrating with. And so on this document, we're going through the basics again. So I pour some of the NaOH into the burette. Again, this is that burette. So I pour some of it in there. I don't know the molarity. We're going to figure it out eventually. So in a flask, I add 0.350 grams of this acid known as potassium hydrogen phthalate. Its molar mass is 204.23 grams per mole. So we're going to go through in general the details of how to do this, of how to determine the molarity of a solution through a titration. So the first question here, we got to figure out how many moles of acid are in my flask. I have my grams and I have the molar mass. So all I'm going to do is go through a very quick mole conversion. Whoops. I'm going to go, let's see, so 0.350 grams of my acid. I'm going to convert it from, here we go, from grams to moles. So in 1 mole of the acid, it says up there I have 204.23 grams of the acid. Do some quick math. I get 0.00171 moles of the acid. Okay. On this document, I'm not going to do all the math for you, but just, oops, wrong one. No, whatever. There we go. But just go, work along with me so you can understand what's kind of going on. So in general here, what I do have are 0.00171 moles of acid in my flask. That's because I just did a gram to mole conversion. So that's actually a crucial number that you need to use later. So in the titration, I add some water to the flask to dissolve the solid. I add some phenolphthalein indicator to the acid. Now down here, I'm going to show a quick video about what the phenolphthalein does. It's going to remain clear. All right, because it's clear in acids. Good. All right, so before beginning the titration, the whole point is that we need to know how much NaOH is required to neutralize the weak acid. Because in the for the indicator, if I add base to an acid, we talked about this before the break, the acid, this potassium hydrogen phthalate, the acid starts to neutralize. And at the end point, what happens is that the solution is completely neutralized. So all of the acid is used up and all the base neutralized it. And so in general, when that happens, you should have a pH slightly higher than 7. So you're going to have a slightly pink solution because all the acid is gone because the base neutralized it. Now, if I add too much base, it turns dark pink, and that's no good. You'll see that in another video. So before we begin the titration, you need to record the level of NaOH in the burette. So burettes, they measure liquid kind of strangely. So over here, I have a picture of what it would look like. All right, and again, the video on this document shows you how to read these things. So I'm going to say that this burette starts, the level of the NaOH starts at 6.63 milliliters. Okay, and then the actual titration begins, where I move, or I were to turn that valve, and the base starts dropping out of the burette and into the flask. All right, and so what happens is it's going to eventually neutralize all the acid, which is what I need to do. And so we're going to get this light pink color once it's all neutralized. If too much base is dropped, you're going to get dark pink, and you're going to see that on, again, a future video. And that's bad because that means you dropped way too much base. It's not completely neutralized now. That means it's too basic and your data is ruined. So when the titration's done, in other words, a perfect pink is visible, you need to record the level of the NaOH in the burette. Again, the level itself doesn't tell you how much is used. So the burette, the original reading was 6.63 milliliters, but the new reading of the burette is 19.70. So if we subtract 19.7 from 6.63, we get 13.07 milliliters of NaOH was used, and for liters that would be 0.01307 liters because 1 liter is 1,000 milliliters. Again, this reading doesn't tell you how much was used, all right, because the original reading was this, and then you used a certain amount of NaOH until the final reading was 19.7. Usually, chemists will start the burette like at the 0 mark, at the 0 milliliter mark, because it's easier. It's at the top of the burette, but it doesn't really matter as long as both values are known. All right, we're almost done. So this one is actually crucial. All right, that's why I have it in highlighter. The base and the acid react in a 1-to-1 ratio. All right, that's like your marshmallow to s'more ratio, 1 marshmallow per s'more. So we already know how many moles of acid were in the flask, right up here. That's why it's in black and yellow. That many moles of acid reacted. So if I know that many moles of acid reacted, that many moles of base also reacted. It has to be the same because it's your 1-to-1 ratio. That's why it's crucial to get the titration to the light pink, because if you use too much base, then your data is ruined. Your volume of NaOH is ruined because there's too much added, and then it's not perfect. That's why a lot of trials are done for titration to get a good average. So at the end, you now know how many moles of base, right up here, and how many liters of base were used in the titration. Moles, liters. You can solve for the molarity of the NaOH. Okay, so you need to use the molarity equation, use the moles there and the liters there, and you can solve for the molarity of the base. That is how titration math is done. So you need to know a certain amount of information about one solution, and then you need to use information about the unknown. In our case, the unknown molarity is what we're trying to solve for. So once you solve for that, make sure to submit this through Haiku. You could take a look at the actual titration homework, but that will be more or less for day 3 of e-learning. Please also check out my my video of actually going through a titration and the color process about what's going on, the easy parts, the hard parts, etc. And if you want, you can always make a titration meme if you wish. I like these. So great. Thanks for watching, guys.